Hello and welcome to class. Today we'll briefly do like a continuation of what we did yesterday. Alright, so today we're going to be dealing with TWI. We're still in hydrology. So we're going to be looking at the Topographic Roughness Index. Yesterday we looked at Stream Power Index and what it does in time of erosion and all that, but we just show you how to create it. So today we're going to do another factor, which is TWI, and TWI is Topographic Roughness Index. So what is this Topographic Roughness Index? It is also known as the Compound Topographic Index, CTI. So anytime you see TWI or CTI, it's a referendum of TWI or CTI. Alright, so what did they say it is? It is a steady state wetness index. It is commonly used to quantify topographic control on hydrological processes. Alright. So the index is a function of both the slope and the upstream contributing area per unit width orthogonal to the flow direction. The index was designed for hill strip catenaries. So accumulation numbers in flat areas will be very large. And the index is highly correlated with several soil attributes such as horizon dip, slip percentage, organic matter content, and the phosphorus. And the method of computing this index differ primarily in the way the upslope contributing area is calculated. So I just wanted to introduce a bit of theory before we get right into the video. Alright, so we're still using ArcGIS, and any version of the ArcGIS from 10.0 is okay. So you don't need to, when you see me using 10.8.2, I say, will it do? It will do. Alright, so just get your ArcGIS set and launch, and then we get started. So this is the video we did yesterday of SPI. So yesterday we covered from clipping the DEM to filling the DEM, and then we created flow direction, we created flow accumulation. Now we created slopes in degrees and also in percent. So today we're going to move further because we're going to be doing Topographic Roughness Index. So for that we are going to create Topographic Roughness Index, we need few more factors. So what we need here will be raster calculator, just like we did yesterday. So bring up your raster calculator. So what we need to find now is the radians of slope, and then we have a slope in degree. So that's what we're going to be using. If you follow the yesterday video, you realize that we created slope in degree. So we're going to be doing radian of the slope. So this radian of the slope will be our factor to do. So let's go on with it. So we have our raster calculator channel, and we're going to insert these formulas. So the slope in degrees will multiply this number I'm going to type now, 1.570 796 1.507 1.570796 divided by 90. Okay, so that's the number, and then we create the output, and we call it radian, because a rat slope. Anyone? Oops. So excuse me. Say radian slope, and then we save, and we're okay. So we have a radian of slope here. So the next we want to create is the time slope. So still on the raster calculator, we'll be punching some few formulas again. So where you need to calculate the time of slope is our slope. Alright? So how do we do that? You insert this formula. Under condition, we say you click on this CON, and then you insert the slope in degrees. And then comma. Comma, then you, okay, not comma yet. So you insert this sign and you put 0. So comma now. Time, the search for time. You scroll through and check for tan. Okay, we have tan. Yeah. So the tan now will be tan of slope in degrees. Then corner. Zero 0.001, and then you close the bracket. So the formula is con slope in degree. Let me copy the formula also and put it in the notepad so that I will also drop the formula for you. Alright, so next now we're going to just save it, and then we're going to save this as tan slope. Then we're going to save, then we OK. Okay, so we have our tan slope now. So I think we basically have OK. We have the last one to create, which is our flow accumulation scaled. So we still need raster calculator. To calculate the flow accumulation scaled, we're still going to punch some formulas again. So we're going to say flow accumulation plus 1. Then you close the bracket. Supposed to open the bracket, close the bracket. Okay. Then multiply by the cell number. Okay, so this time around we need to go and get cell number. So what is the cell number? Let's go to flow accumulation and cell size, sorry, not cell number. And the source, we have a cell size here. So you copy this. Let's also check that of the dim, whether they are the same. Yeah, they are the same. So you copy this the cell size from there, and you paste it. Then let's close the bracket. Open the bracket and close. All right. What is this brother saying now? Okay, yeah. So we're going to name it accumulation scaled. Accumulation scaled. And we're going to save, then we're okay. So also our accumulation scale has been created. So basically we have all we need now to create our topographic wetness index. So what is now the formula for topographic wetness index? So we still bring out our raster calculator. So the formula for calculating topographic wetness index is equal to ln flow accumulation scale divided by tan slope. So slow the ln into bracket of the accumulation scale we created, and then the tan slope, you divide them, and then you have your topographic wetness index. So now we're going to save this as TWI, topographic wetness index. So we're going to click on OK and wait for our result. So I think that's done. So we right click on it and go to properties of the TWI, and then you go to symbology. Now we're going to click on classified. So we're going to still use the 5 class, and let's check another symbology. Okay, let's use this. So you click on labels, so you can easily click on the format, and let's reduce this to 3, and that's okay. So let's click on OK. So if you look at here, you're going to see more like, yeah, you can see. So this is River Kaduna. Then I think these are injunctions of other little streams. So these are the wetness index of this area. Yeah. So basically I think this is where we have to offer today. We'll see you in the next video, but before you log out of this video, don't forget to like, share, comment, send to friends, loved ones, and keep engaging on our videos as we bring in back-to-back content from this channel. This remains Eli Geospatial, and I'll see you in the next video.